for number 1, if I want to graph this rational function, in order to find all the important information, or to make it easier for me to find all the important information that I need, I am going to factor this thing. I notice in the numerator that these terms have a greatest common factor. I always have to check for that first. Since they have a greatest common factor, I'm going to take that greatest common factor out. I know that each of them share x in common, so I can rewrite this as x times x squared minus 5x plus 4. I actually want to write that on the top here so I have enough space to do everything else. On the bottom, I also notice there's a GCF of x, so I take an x out, and I can rewrite this as x times x squared minus 4. Then when I factor further, I have x times that this polynomial. I know I can factor to be x minus 4 times x minus 1, because negative 4 times negative 1 gives me 4, and if I add them together, I get negative 5. In the denominator, I have x times x plus 2 times x minus 2. I have the difference of two squares. I can separate them into the first thing that was being squared as the first term, and the second thing that was being squared as the second term, and then one is addition and one is subtraction. From here, I can cancel out the x's in the top and the bottom. They cancel out, and I'm left with just x minus 4 times x minus 1 all over x plus 2 times x minus 2. This is my final equation that I'm going to use for most of these things, except for the wholes. To find the wholes are the x values that made the denominator 0 that canceled. So I need to take into consideration that those, or whatever x value made that thing 0, is not included in the graph. So it's an open circle. It's a hole at that point for x. Here, x would be 0 for x to be 0. So I know my x term is 0, and I want to look for what my y term would be. I plug in 0 into this final equation, so I get negative 4 times negative 1, so I do make f of 0, over 2 times negative 2, I get 4 over negative 4, which is negative 1. So I have 0, negative 1 as my point. From there, I'm going to find my vertical asymptotes. So I'm going to look in the final equation. For what would make that denominator equal to 0. What x value is? Well, x is equal to negative 2 is 1, and x is equal to positive 2 is another. So x is negative 2 from this one, and x is positive 2 from this one, that factor. The domain I know is based off of my wholes and vertical asymptotes. So those x values are not included. So 0 is not included, negative 2 is not included, and 2 is not included. So I know that I'm starting at negative infinity. I'm going to, what's the smallest one that I have here? Negative 2. So if I write these in order, I have negative 2, 0, and 2 are excluded. So I'm going to have 3 breaks, which means I have negative infinity to negative 2. That's my first interval. Then I have to talk about negative 2 to 0. That's my second interval. Then I have to talk about 0 to 2. That's my third interval. And then my last interval is 2 to infinity. So I've included all of my breaks. I had a break at negative 2. I had a break at 0. I had a break at positive 2. The next thing I'm going to look for is horizontal asymptotes or oblique asymptotes. I'm looking for what the end behavior is when I look for horizontal asymptotes and oblique asymptotes. Oblique asymptotes is just another way of saying slant asymptote. So this also means slant asymptote. I know that I'm comparing the highest powers. I have x cubed and x cubed. That means since the numerator power is the same as the denominator power, I know that I have a horizontal asymptote. And the horizontal asymptote is going to be where y is equal to, so the horizontal asymptote is y is equal to 1, since it's 1 over 1, the coefficients, the ratio between the coefficients. My end behavior is based off of that horizontal asymptote. So to write the end behavior, I just write the limit as x goes to positive or negative infinity of f of x is equal to 1. And that's how I write it. I'm not going to circle that because because I didn't circle anything else. And then my y-intercept, I'm looking for my y-intercept. I'm plugging in x is equal to 0. I found that point already, and there was a hole there, so I know that there is no y-intercept. Because if I plugged in that 0 into this function, I would have had 0 in the denominator. To find my zeros, that's also my x-intercepts. I'm looking for what would make the numerator equal to 0. So the numerator would be 0 when x is equal to 4 from there, and when x is equal to 1 from there. So I have 4, 0 and 1, 0. And then I'm going to just plot all of this important information. So I'm going down here, and the first thing I'm plotting is a hole at 0, -1. So I have a hole here. I have my zeros are 4, 0 and 1, 0. So 4, 0 and 1, 0. My vertical asymptotes are -2 and 2, so -2 here and +2 here. And then I have my horizontal asymptote is at y is equal to 1. So it's here, and that's just going to describe my end behavior, so I'm just going to put it on the ends. From here, I'm going to tell what everything's going to look like. I'm going to plug in points and see, well, on the right-hand side, I know that as I go to the left, I have to approach that vertical asymptote. I could check a point, though, just to make sure, so I'm going to do that just to make sure. A point to the left of 4, 0, and that will be where x is 3. And then I'm plugging so I'm doing f of 3. So f of 3, which is going to be 3 minus 4, which is -1, 3 minus 1, which is 2, and then I have 3 plus 2, which is 5, and 3 minus 2, which is 1. I'm going to get -2 fifths. So I know it's -2 fifths. And so I should be going downwards, 3 and -2 fifths. So yes, I'm going downwards as I approach that vertical asymptote. And then as I go to the right, my end behavior is that I am approaching the horizontal asymptote. So that's what the right-hand side is going to look like. Since I only have one x-intercept here, I should not be turning around because then I would have had another x-intercept. I should just be going through this point and up, and then hitting that vertical asymptote upwards. I was hitting it downwards over here, so I'm hitting it upwards over here. And then as I go to the left, I should be going downwards, because if I was going upwards, then I would have had another x-intercept. So I know that I'm going downwards. I don't need to check another point, but you can always check another point if you want to. And then based on all of that, I know that I should be approaching this vertical asymptote. I should be approaching it upwards from the left. And then as I go to the left, I'm approaching that horizontal asymptote. So that's what my P should look like, but I should always check another point just to make sure. So if I wanted to check another point, I would check f of -3, and that would give me f of -3 would be -7 times -4 over -1 times -5. So that would be 28 over 5, which is like, if I estimate it, it's like 5 point something. And so that was -3. And so I should be at -3 and 5 point something. 1, 2, 3. Yeah, that looks right. Okay, and that is number 1.